Hi guys, welcome to this video lesson. We are going to be talking about slopes of parallel and perpendicular lines today. And this is the last lesson of chapter 3, which was all about parallel and perpendicular lines. So let's talk a little bit about parallel lines to start off with. Two non-vertical lines are parallel if they have the same slope. That's what we need here. Okay, so we've learned a good deal about parallel lines in geometry. We know that they never intersect. We know that they have to be coplanar and in the same plane. And now you need to add to it that their lines have to have the same slope, exactly the same. Okay. Now, if that is the case, that will also tell us that all vertical lines are parallel to each other. And also all horizontal lines are going to always be parallel to each other. And that should make sense because visually we would know that they're never going to cross and they appear to have the same slope, but also mathematically we can see that as well. Okay. So let's get a pair of vertical lines right here. Okay, and then also horizontal lines are going to be parallel too. Okay. Now let's move on to perpendicular lines. Two lines are perpendicular if and only if their slopes are what we call negative reciprocals. What are negative reciprocals? I'm glad you asked. We're going to talk about that. So negative means they're basically opposite. One is positive, one is negative, or vice versa. One is negative, one is positive. Okay, so that's what we mean by negative. And then reciprocal, if you remember back when you were learning about fractions in elementary school, reciprocals mean the fraction has been flipped. Okay, so let's have an example here to the side of negative reciprocals. So let's say that one of the slopes is 5/7, positive 5/7. A negative reciprocal of that would be negative, because that one was positive, this one becomes negative, 7/5. Okay, that's negative reciprocals. Let's try another one. Let's say we have -3 as one of the slopes. The negative reciprocal would become positive, right? Because they're opposite. But you also have to flip the fraction. And you're probably thinking, but there is no fraction right here. And so what you would do is make it a fraction by putting 1 on the bottom. And now the reciprocal becomes 1/3. Okay. So that's an example of how you do negative reciprocals. These particular slopes are perpendicular to each other, right? Now, vertical and horizontal lines are always perpendicular to each other. Let's talk about the symbols. There are some abbreviations for perpendicular. You may see this, or you might want to use it. It's upside down. T is the symbol for perpendicular. And let's get an example of vertical and parallel lines being perpendicular to each other. I mean, vertical and horizontal. So you see these cross, and they don't just intersect. Perpendicular means they intersect to create right angles. And I know you knew that already. But it creates 4 right angles. Okay. So that's what it means to be perpendicular. This is the abbreviation. Okay. So those are the notes for this section. Let's get into some examples. The directions say, write the slope-intercept form of the equation of the line described. So that means we are writing equations of lines, but specifically in slope-intercept form. Pay attention to the instructions. They do tell you right out the bat, slope-intercept form, so you know you're going to have to use your formula, y equals mx plus b. Now what's important? Okay, in question 2, it says the line must go through -2, -3, has to go through that point, also needs to be parallel to this line. Okay, so some very important pieces of information provided. Let's pick those things out. We get a point. Anytime you get a point, then you have the opportunity to use the x and the y. Okay, remember, ordered pairs, the first number is x always, and the second number is always y. You might not always use that information, but it is something that you could do when you have a point. Next, we get parallel. That's important because we know parallel means same slope. And this line is important because this equation of this line is written in slope-intercept form, and that means the number in front of x is the slope. So I have a little circle there highlighting the invisible number in front of x. Okay, so here's all the important information. X, y, parallel, which is same slope, and then the slope, which appears to be invisible right here. Okay, so if you don't see the number in front of x, that's a 1. Okay, it's just a simplification thing. They don't write 1x, but m is 1. All right, so we took all that time to identify what was important, and now we're going to substitute all the important information into our formula. Okay, so we have x, y, and m. That's just about everything. Let's start substituting in. What's y? Y is -3 equals m is 1, x is -2, and we don't have b. That's what we will need to solve for so that we can rewrite the equation. Okay, so 1 times -2 is -2. And to solve for b, we just add 2 to both sides. It's going to be a -1. Okay, so now we have everything we need. When I say everything that we needed an m and b. When you write your final answer, you only use m and b. X will stay x, y will stay y when you write your final answer. So let's get ready to do that. Y equals m is 1. You can write 1x, but if you're highly skilled mathematicians would not write 1x, okay? Invisible 1, then x. And then now you need to put b, and b is -1, so -1. You don't need to put plus -1. And this is your final answer. This is the equation of a line in slope-intercept form that has the same slope as this equation, and it goes through this point. This is your final answer, okay? So recapping, what did we do? We picked out the important information. Number 2, we substituted that information into the formula. We solved for the missing variable. In this case, it was b. And then the last step, step 4, is to rewrite the final answer. Okay, again, number 1, we picked out the important information. Number 2, we substituted into the formula. Number 3, we solved for the unknown variable. And then 4, we rewrote the equation. Okay, so let's do a few more. Looking at number 4, same instructions, write the equation of a line in slope-intercept form that goes through this point, but this time perpendicular to this equation. Okay, what do we need to do? Pick out the important information. I'll go ahead and get my formula down here. Then I'll pick out the important information. Okay, so this point is important. We know that always gives us x, y. Perpendicular is important. That is going to help us with our slope. We know we need negative reciprocals. And this equation is important, specifically the slope of this equation, which is 3/4. Now, we want to use a perpendicular slope. Perpendicular slope means we need to take this slope that was given. We need to do the negative of it, right? This positive, we need to do the negative. And we need to flip it so it will become 4/3. Okay, so the slope we need to use in this problem is -4/3. That's what we need to use. So now we're ready to substitute everything in. Y is 1. Slope, -4/3. X, -3. And B, we don't know. That's what we're going to have to solve for. Okay, so we picked out the important information. We've now substituted it into our formula. So let's solve for B. We have a 3 on top, 3 on the bottom. Those will cancel. And then we have -4 and a negative, which is going to give us a +4. So remember, anytime you have the same number on top as you do on the bottom, that's a beautiful thing because they will just cancel. So the 3's just virtually went away, okay? And double negative becomes positive. When we solve for B, we'll subtract 4 on both sides, and we end up with a -3. Is B. Now we have everything we need to write our final answer. We have the B and the M. And now we just need to write that answer. Y equals -4/3 X, and then B is -3, so -3. And that is our answer. Equation of a line that goes through this point that is perpendicular to this slope. Okay. You will do 5 and 6 the exact same way. Let's look here at this section. The directions tell us to determine whether the lines are parallel, perpendicular, or neither. Let's take a look at question 8. It says y equals 3. Notice there's no other information, no x in there. And the other line is x equals -2, and that one is just basic. It doesn't have anything about a y. So these types of lines, these are the horizontal and vertical lines that we talked about. We saw this in the last section too. Anytime you have a y equals, that's going to be horizontal. If you just have y equals a number and nothing else, That's always a horizontal line, and x equals a number is always a vertical line. Okay? And so we can be very clever here and not do any calculations if we remember the theory. Horizontal and vertical lines are always perpendicular. So the answer to this one is perpendicular. And I'm just going to write my symbol instead of writing that word all the way out. Okay. All right, let's take a look at number 10, and this will be the last one for this video. It says a parallelogram is a quadrilateral, that means four-sided shape, that has opposite sides that are parallel. Is quadrilateral ABCD a parallelogram? Why or why not? And then they give us the coordinates of all the points for A, B, C, D. Now, you don't necessarily have to plot the points and see the parallelogram to do this problem, but I like to have a visual, and there's a grid provided, so why not? We need to plot the 4 points. So A is 0, 2. Label that as A. Next, we have B, which is 3, 4. So over to 3, then up to 4. Now we have C, which is 2, 7. Over to 2, up to 7, which is not on here. And D, negative 1, 5. Okay. Let's connect the dots for our parallelogram or quadrilateral. We don't know if it's a parallelogram or not yet. And remember, I connected these points, so do not go by looks, we will go by math, okay? So it doesn't matter if you think the lines look to be parallel or not. That's not what we're going by. We will do the math. So what sides are opposite? That's what we need to know, because it tells us in a parallelogram, opposite sides are parallel. So what are our two pairs of opposite sides? DC is opposite AB. So we need to know, is DC parallel to AB? Okay. And then we also need to know if DA is parallel to CB. How can we check if they're truly parallel? Remember, we learned earlier that parallel lines have the same slope. So essentially what we can do is find the slope of DC and AB. If they're equal, then they're parallel. Then we can find the slopes of DA and CB. If they are equal, then they are parallel, and then we'll know yes or not, yes or no, if this quadrilateral is a parallelogram. So let's get busy. When you find slope and you have 2 points, you can use the formula we learned in the last lesson, which is y2 minus y1 over x2 minus x1. Okay, so that's what we'll use. We also saw this back in the first unit of geometry this year. So this is a recap. So let's do D and C. Here's D, here's C, finding those. I'm substituting in. That would be 5 minus 7. And then negative 1 minus 2. 5 minus 7 is negative 2. Okay. And negative 1 minus 2 is negative 3. So that's the slope of DC. Now let's find the slope of AB. We'll do 4 minus 2. Let's pull in the points from right here. And 3 minus 0. 4 minus 2 is 2. 3 minus 0 is 3. Are these the same? Yes, they are, right? Because this double negative is the same thing as 2/3 when you simplify. So those are parallel mathematically. They look like it, but also we proved that they are parallel because their slopes are the same. But we can't stop there. We have to check the other two. And that's the only way we can say with certainty that this is a parallelogram. So we'll do DA. This time I'm using point D and point A. 5 minus 2 over -1 minus 0. 5 minus 2 is 3. -1 minus 0 is -1. Okay. So our slope comes out to be -3 if we simplify right here. One more to go, C and B. 7 minus 4. 2 minus 3. 7 minus 4 is 3. And 2 minus 3 is -1. Look at that. Identical. So DC is parallel to AB. DA is parallel to CB. This is yes. Yes, it is a parallelogram. Why? Because opposite sides are parallel because their slopes were equal. Okay. Guys, I hope you learned a lot in this lesson. If you have any questions at all, you know what to do. Put your comment below, send a message, or ask your questions in small group. Have a great day.